Hi everyone, and welcome to our next tutorial on digital logic. In the last video we took a look at how AND gates, OR gates, and NOT gates function using a program called CircuitVerse. We're going to continue with that program, and we're going to take a look at a couple more gates in this video. We're going to take a look at one very similar to an AND gate. In fact, we're going to pull out an AND gate here. And just to review what we did here, this is a 2-input AND gate, and if we connect our inputs to that AND gate and then connect the output, we can see that it functions as expected. When both inputs are on, the output is on. If either one of the outputs is off, then the output is off, or it's a low signal. Now, if I just delete this here, and I'm going to grab an inverter, and if I put an inverter in between here and connect this, then as you would expect, when both inputs are low, that produces a low out of the AND gate. The inverter, though, converts it to a high signal, so we get this here. If I pull out this here, this is called a NAND gate, and if I grab the inputs, this is a 2-input NAND gate, and I grab the output like so, and I wire this like so. You can see that this digital logic circuit behaves exactly the same as this one. If I put this as a high signal and this is a high, you can see that both of the inputs are high. If we put this back and put this to low, or this to high and this to high, and again you can see that the outputs are the same. If both inputs are high, then we get the same output. In other words, the circuit for this logic circuit is the same output for this one here. In other words, the truth table for this is the same as the truth table for this here. An AND with a inverter at the end is really the same as a NAND gate, which looks like an AND symbol with this symbol or bubble at the end. That's an example of a NAND gate. If we delete this here and delete this here, and I'm going to bring in one of the gates that we did before, and that was an OR gate. If I bring in this OR gate and we wire this up as so, and if we run this here, as we would expect in this case here, these are both a low going into the OR gate. That produces a high output, but that inverts it. Or sorry, it produces a low, which inverts it here and produces a high. If one of these is a high input, that produces a high output. It gets inverted to a low. If both of these are high, that produces a high output. This inverts it to a low. If I go and grab this here, this is a NOR gate, and as you probably would expect, it's going to behave the same way as the circuit above. Let's just hook it up and confirm that it does. So you can see in this case here, both inputs are high. This is a low output. This is a low output. If both are low, you can see that both of these are a high output. If this one here is high and this one here is high, again, we would expect these to be the same. If this is a high here and this is a high here, again, you can see that these are the same. So this is called a NOR gate. It is an OR followed by an inverter, which we can see here. And those are two new logic gates for you to learn, the NAND gate and the NOR gate. That's it for this tutorial. Take care. We'll talk to you soon.